Okay, let's go ahead and get started. Today we're in the laboratory and we're going to be doing a procedure that's known as a titration. And a titration is really a very carefully controlled, very precise determination of the concentration either of an acid or a base. In this case, we're going to be determining the concentration, which is now unknown, of this hydrochloric acid. So the hydrochloric acid that we have here is a strong acid, of course. It's a monoprotic acid, but we don't know the concentration. And that's what we're going to try to determine today. To do that, we're going to be using a known concentration of sodium hydroxide. This is a 0.1 molar sodium hydroxide solution. It's a strong base. So we call this the titrant. So once again, we're going to be attempting to determine the concentration of the hydrochloric acid, the currently unknown hydrochloric acid concentration, with a known concentration and a known volume of 0.1 molar sodium hydroxide. Before we actually begin the procedure, though, I want to talk a little bit about how we approach the apparatus itself and the preliminary things that need to be done. As you approach the apparatus, you'll know that the long, slender tube that you see before you, that's known as a burette, is in the upside down position. So the very first thing you're going to want to do is remove it from the stand and just invert it. Place the stopcock in the bottom of the apparatus, in the bottom of the burette. This is the stopcock here. And it should be in the horizontal position, that is with the handle at 90 degrees to the actual burette itself. First thing we're going to want to do is do a thorough cleaning of the burette. And I'll use distilled deionized water. You certainly don't have to fill the burette, just 10 or 15 milliliters will do. Just gently around the sides of the apparatus, just like that. We'll open that up and allow that to flow through. This is going to allow any residual fluid that was in from previous experiments to leave the burette. And just let it flow through just like that. The next thing I'm going to do is I'm going to follow that with a little bit of the titrant. Not much again, just enough to coat the walls. I'll close that once again, just like that. And at this point, I'll use a funnel and also make absolutely sure at this point that you're wearing safety goggles. You certainly should be wearing safety goggles at all times, but when you're doing a titration like this, when you're pouring above your head, it's very important that you have the proper eyewear. So make sure you have goggles on at all times. So I'll just allow that to flow through the burette, and that completely clears the burette of any residual liquid that was during previous experiments. So I'm going to move now from this burette to this one. It's already been loaded with 50 milliliters of sodium hydroxide. You don't have to start with 50 milliliters. You can start with any amount. Just make sure that you notate in your laboratory notebook your starting place and your stopping place. So you recall we're going to attempt to determine the concentration, the unknown concentration at this point of the hydrochloric acid. And so to do that, I need to first of all determine a set volume, a known volume of the hydrochloric acid. In my experiment, I'm going to be using 20 milliliters of hydrochloric acid. And I've filled 2 graduated cylinders, each with 10 milliliters, just like that. And I'll drop those into my flask just like that. Okay? Now, the next thing I'm going to do is I'm going to add an indicator. In this case, my indicator is phenolphthalein. Phenolphthalein is an indicator which at low pHs less than 7, appears clear in solution. And at high pHs is a light pink. So I'm going to add phenolphthalein to the flask just like that. 2 or 3 drops, no more than 2 or 3 drops. And that goes in the flask just like that, and I'll swirl that around just like that. All right. I'm going to be in my titration now. Remember that I've got loaded in the burette the sodium hydroxide solution, the known concentration, 0.10 molar sodium hydroxide. And I'm going to be using my non-dominant hand to control the stopcock, and my dominant hand, I'm right-handed, to control the swirling of the flask. So we'll just begin. At the beginning of the titration, I'll go fairly quickly because of the fact that I know it's going to require a number of milliliters to reach a neutralization, a titration in other words. And as those drops are falling, I'll just describe what's happening. In the flask in my right hand, I've got hydrochloric acid. Now when hydrochloric acid is placed into water, it dissociates into hydronium ions. And those hydronium ions are causing the pH to be very low inside the flask. But slowly I'm adding a hydroxide. And those hydroxide ions from the burette are combining with the hydronium ions to form water and ultimately salt, NaCl. Okay? And that's the neutralization. So as I continue to drop the drops slowly into the flask, neutralization is beginning to occur. I'm beginning to see some hint of pink in the flask itself, but it's certainly not sustained at this point. Okay, I can see the pink now. Certainly not sustained, but I'll have to slow down here because the pink is continuing in the solution for a longer and longer period. So I know I'm getting fairly close. So I'll have to slow the flow down just a little bit. And again, we don't want a dark pink. As a matter of fact, I'm getting very close now. We don't want a dark pink. I think I'm within a couple of drops of titration. As I'm doing this titration, I'm not even bothering to look up at the burette to see how much volume has left the burette because of the fact that my concern is with the color in the flask at this point. I'm getting very, very close to a sustained pink. And I think we're there. Yes, we're there. Notice it's not and I'm not sure how well the camera's picking this up, but it's not a dark, dark pink. It's just a very, very faint pink. Very faint pink. But that is the titration. That's the titration. A very faint pink. I'll hold it up to my sleeve just like that to give you a better view of that. But a very faint pink represents the titration. So I'll place that right there. At this point, I'll look to see how much of the titrant that was used. It is 32.2 milliliters, 32.2 milliliters of sodium hydroxide used to titrate 20 milliliters of the hydrochloric acid. And we now have our titration. Okay, that completes the titration itself. We're going to go over to the board now. We're going to talk a little bit about the calculations that are necessary in order to determine the molarity then of our hydrochloric acid. I'll see you there.